Hello, and welcome to the compounding continuously video. This is one of the equations we're going to be using when we are dealing with our exponential functions, specifically when we are compounding continuously. This page comes from a worksheet where we would have discovered E. What does that look like? This is the second page with a few problems. So we're going to work on two of these. I'm going to leave the other two for us for our Go formative. A few things I want to point out is we would have noticed that if we had taken E and plugged that into our calculator with e to the 1, we would have gotten about 2.71, like I said in my previous video. And it was a man named Bernoulli who found that as n, or your number of times per year, got larger and larger and larger in this number of times per year equation, we would have eventually got to here. So this involves limits. That was a very, very general explanation, but we're going to be using this equation right here when we go through and compound continuously. Just a reminder, I'm going to write this off to the side. A is your end amount. P is your principal value or your start amount. E is just a number, so that's always going to be E. R is your rate or your percentage. And then T, I just got an email. T is going to be time, usually in years. So you're also going to hear me call this the PERT equation, just because P-E-R-T spells PERT. So let's take a look at that very first problem, problem number 3. So right here. So this one's talking about a loan shark, and we're going to zoom in so we can see that just a little bit better. So see, a loan shark lends a gambler $1,000 to cover a debt. Okay, so $1,000 right here. We are starting with that $1,000, so that is going to be P. That's our start. He charges 35% annual interest compounded continuously. Okay, if you see this compounded continuously, that's when you know we're going to be using the PERT equation. And that 35%, I highlighted that because that is our rate. If we were going to change that into a decimal, that's going to be, I'm going to write this over here, 0.35. So that's going to be our rate we're going to use. Let's see, let's go back here. Because he can't pay, the gambler skips town for a few years until he earns enough money to pay his debt. How much does the gambler owe the loan shark when he returns 2 years later? Okay, I'm going to highlight, there we go, that 2 years later, because that's going to be our time. So this is our T, and again, this was our R. So we have everything we need. Let's set up our equation. So let's see, we're going to say that A is equal to, and I'm going to zoom in a little bit more, A is equal to our start amount of $1,000 times E to the 0.35, that's our rate, times T. So whatever our time is going to be. In this case, it's going to be 2 years. So when we solve for this, we're going to say that like A of 2, we can look at it this way. A of 2 is 1,000 times E to the 0.35 times 2, because that's after 2 years, or 1,000 times E to the 0.70. When I plug this into my calculator, I get 2013.75. I actually get a much longer decimal than this, but since we're dealing with money, again, remember, we're only rounding to the second decimal place. So that's all you need to do. Once you have the equation, you plug in your time, and you're good. The last thing we need to do is write a sentence, because it is a story problem. So the gambler owes $2,013.75 after 2 years. So there we are. So I'm going to do number 5 next, but I'm just going to say for number 4, your start amount is a penny. So think of that in terms of dollars. Think about your start amount in terms of dollars, and how would you write a penny? But this is when we're dealing with interest compounded continuously, but it can be actually, you can use this equation to solve for other things. So let's take a look at problem number 5. Oops. So take a look at problem number 5. So problem number 5 says radioactive iodine used by doctors as a tracer in diagnosing certain thyroid gland disorders. This type of iodine decays in such a way that the mass remaining after T days is given by this function right here. So we're actually already given a function where m of t is measured in grams. Find the size of the mass when t equals 0. So this is when our time equals 0. So like when we start our time. Then find how much of the mass remains after 45 days. Okay, so now we're plugging in our days and seeing what does this mean. So for our first equation, we're going to have two equations for this one. We'll have m of 0 is 6, so it started, looks like with 6 grams, times e to the negative 0.087, that's our rate, times our time of 0. We're going to have 6 times e to the 0, since anything times 0 is 0. And then since e to the 0, or anything to the power of 0, is 1, this just becomes 6. So you may have also known that by knowing that p, our principal value, or that number out in front, is also going to be our start value. So we can say the mass is 6 grams on day 0, but that's not all it's asking for. It's asking after 45 days. So m of 45 is going to be 6, so we're starting with 6 grams times e to the negative 0.087 as our rate times 45 days. Now we're using days because t has already been established as days, so after t days, normally it is in years. But once we plug this in, we can start solving. So this is going to be 6 times e to the power of negative 3.915. Once we plug that into our calculator, we get 0.1196. So for a sentence, we can say the mass is 0.1196 grams on day 45. And this is important because it shows that the mass has shrunk considerably. So this is something we actually might use to see if the efficacy of these iodines or their treatment that they're using. So that was just using this equation. Hopefully it wasn't too bad. I'm going to be putting problems 4 and 6 on the Go Formative and maybe just a few more. Let me know if you have any questions.